Hey everyone, today we're going to dive deep into a document that's a total game changer in the fight against non-small cell lung cancer, the Biomarker report. Now, if you're a pathology trainee, getting this right isn't just about checking boxes. It's about literally steering a patient's entire treatment journey. So let's break down exactly how you do that. So let's just start with the biggest question of all, right? In this whole new world of personalized medicine, how does your report, the one you're going to write, actually save a life? Well, it all comes down to being precise, being clear, and most importantly, following a standard. All right, here's the plan. We'll quickly cover why a standard report is so critical. Then we'll walk through the CAP template. We'll start with the basics, the specimen itself, then jump into the really key stuff, the driver mutations and immunotherapy markers. And we'll wrap it all up by talking about the massive clinical impact your work has. So first up, why does this matter so much? Before we had standardized templates, pathology reports were kind of like the Wild West. They could be completely different from lab to lab, even from one pathologist to the next. And that, as you can imagine, created a huge headache for oncologists. And here's the bottom line. When a report is confusing, or it's missing information, or it just uses weird phrasing, that can cause a delay in getting the right drug to the right patient. And in oncology, a delay is something you just can't afford. The stakes are just way, way too high. So what's the fix? Well, the answer is the CAP template. You have to think of this as the gold standard, the one tool that makes sure every oncologist gets the exact same critical information every single time. This solution comes to us from the College of American Pathologists, or CAP. These are the folks who develop these incredibly detailed templates that basically walk you through the entire reporting process. Seriously, think of it like a pilot's pre-flight checklist, but for cancer diagnostics. It's that important. The official name for this method is synoptic reporting. So instead of writing out a long story in a paragraph, it's a structured checklist. And this is brilliant because it forces you to be complete. You literally can't forget a key biomarker. And it makes it super easy for a busy clinician to find what they need in like 5 seconds. All right, let's get practical. Every single great report begins with the tissue itself. Before you even think about genes or proteins, the CAP template makes you stop and assess the quality of the specimen you're even working with. This is the foundation, and if the foundation is shaky, the whole report is useless. These are the first crucial questions you have to answer. Is this sample even good enough for testing? How much of this tissue is actually tumor? And is this a brand new diagnosis, or is this cancer that's come back after treatment? Getting these answers right up front saves everybody a ton of time and makes sure your results are actually reliable. Okay, now we get to the really cool stuff, the heart of personalized medicine, hunting for those driver mutations. These are the specific genetic typos that are actually telling the cancer to grow. And if you can find them, it's like finding the enemy's command center. It gives the oncologist a perfect target for therapy. Let's use EGFR as a classic example, because it really shows you how nuanced this is. If you find something like an exon 19 deletion or an L858R mutation, that's fantastic news. It means the patient is super likely to respond to a certain class of drugs. But if you find a T790M mutation in that same gene, that signals the opposite. It means resistance. Your report has to make that distinction crystal clear. Okay, so we've got mutations down, but next step are ALK and ROS1. These aren't about simple mutations. They're about a totally different kind of genetic mess-up called a rearrangement or a fusion. Let's look at those. So for these genes, your job is to figure out if the gene has literally been snapped in half and fused to a different one, like the famous EML4-ALK fusion. Finding a positive results, whether you use IHC or molecular methods, swings open the door to another set of incredibly powerful targeted drugs. The template makes sure you note this and even lets you get specific about the fusion partner. And you see the exact same logic for other genes, like BRAF. This table shows it perfectly. You find a specific mutation, like V600E, and that is directly tied to whether a BRAF inhibitor drug will work. Your report is that final, definitive link between what you see under the microscope and what the oncologist puts in the prescription. And believe me, the list just keeps going. The full CAP template is incredibly comprehensive. It covers KRAS, RET, MET, and a whole bunch of others. But they all follow the same simple rule. Find the specific change, and then clearly state what it means for the patient's treatment. It's all about systematically unlocking that tumor's secrets. Okay, let's totally switch gears now. We're moving away from targeted therapy and into immunotherapy. With these markers, we're not looking for a genetic weak spot to attack with a drug. Nope. Here, we're trying to figure out if we can just take the handcuffs off the patient's own immune system and let it fight the cancer. Now, the big one for immunotherapy in lung cancer is PD-L1, and we test for it with immunohistochemistry. But here's the catch. The template makes you specify which antibody clone you used, like 22.3C or SP263, because different clones are linked to different FDA-approved drugs. You have to get the context right.
And it's not enough to just say positive or negative. You have to give a score. The two big ones are the TPS, or tumor proportion score, which just looks at tumor cells, and the CPS, or combined positive score, which looks at both tumor cells and immune cells. Getting these scores right is absolutely 100% critical for deciding treatment.
And that's not the whole story for immunotherapy. The template also has spots for tumor mutational burden, or TMB, and microsatellite instability, or MSI. If either of these is high, that can be another really strong signal that the patient will respond well to immune-based treatments. So let's step back and look at the big picture. After you've gone through the specimen details, all the driver mutations, and the immunotherapy markers, what have you actually made? You've built an incredibly detailed, actionable blueprint for one specific person's cancer treatment. I really want this to sink in. Your report isn't the end of the line. It's the starting gun. Every single field you fill out, every result you sign off on, it's not just data. It's the very first step on a patient's road to recovery, and it guides everything the clinical team does from here on out. And that's the main takeaway today. A complete, accurate, standardized report is the absolute foundation of modern, personalized cancer care. It empowers the whole team, it saves precious time, and it leads directly to better outcomes for patients. Your role in this is completely indispensable. And I'll leave you with this final thought. The CAP template isn't set in stone. It's a living document. It gets updated all the time as we discover new biomarkers and approve new drugs. So the real question for you as a future pathologist is, how are you going to keep up? How will you make sure your reporting continues to evolve right alongside the science to be as life-saving as it possibly can be?